92%, that's the statistical anomaly nobody discusses. 92% of commercial buildings constructed in American cities between 1850 and 1890 show architectural features indicating original ground floor access at elevations 8 to 16 feet below current street level, not settling, not foundation problems. Deliberate design for ground plane that no longer exists. The number comes from architectural survey conducted by National Park Service in 1994, examining 847 pre-1890 commercial structures across 23 cities. The survey documented door openings below current basement level, window arrangements designed for street-facing retail at elevations now underground, decorative stonework on lower facades currently buried beneath sidewalks. The findings were filed as technical report, never incorporated into official architectural histories, never used to question whether American city ground levels changed dramatically during the late 1800s. The 92% just sits in archives proving that almost every old commercial building in America had a first floor that isn't there anymore. The door evidence is what makes denial impossible. Not the grand entrance doors at current street level. Those were added later, show different construction techniques, use materials unavailable when buildings were originally constructed. The original doors. The ones below current basement level. The ones discovered during renovation work when contractors excavate for utility upgrades, and find intact doorframes with hardware still attached, with threshold stones showing wear patterns from foot traffic, with door jambs at elevations that make sense only if street level was 10-15 feet lower than current grade. The doors aren't decorative, aren't symbolic, are functional entrances with working locks, with transom windows above, with adjacent display windows on either side, standard commercial storefront configuration, except it's underground now, buried by whatever raised American street levels uniformly across dozens of cities during the same 40-year period. Boston's Faneuil Hall district shows the pattern perfectly. Building after building with sealed doorways at current basement level, not rough openings. Finished doorways with architraves, with decorative elements, with details matching the quality of upper floor exterior work. Building permits from 1880s, 1910s show ground floor entrance modifications, converting below-grade doors to ventilation openings or permanently sealing them. The modifications happen to multiple buildings on the same block in the same year, not random maintenance. Coordinated response to changed conditions. The permit language acknowledges the change without explaining cause. Doors that were at grade needed modification because they ended up below grade. Why did streets rise while buildings stayed in place? The permits don't say. Just document the adaptation. Chicago's Loop District demolished dozens of buildings in the 1920s, 1930s during redevelopment. Demolition photographs show structures being torn down, revealing lower stories that contemporary Chicagoans had never seen. Photographs show brick facades extending 12 to 15 feet below street level. Show window openings at those buried levels. Show architectural details continuing downward. The demolition crews called them phantom floors, fully constructed stories that existed below current ground level. The photographs were filed with demolition permits, were used to calculate debris volume, were never published in architectural journals or newspapers because they raised questions nobody wanted to answer about why Chicago's buildings had hidden floors, and when those floors disappeared beneath street level. New York's property records contain the accounting proof. Tax assessments from 1870s describe buildings as three-story commercial with ground floor retail. Same buildings in 1890s, tax records become two-story commercial with basement storage. The floor count dropped, but the buildings didn't shrink. The ground floor became the basement when street level rose. Property values declined because retail space with street frontage became below-grade storage space. The reassessments document widespread property devaluation during the 1880s as functional floor counts decreased across entire districts. Owners filed appeals claiming the value loss wasn't their fault. Appeals were denied because cities classified the changes as general street improvements, not specific to individual properties, despite every property on affected blocks losing ground floor functionality simultaneously. San Francisco's 1906 earthquake created natural experiment in archaeological excavation. Buildings damaged by earthquake were demolished, revealing their full height, including portions below street level. Photographs from the cleanup show structures with clearly defined ground floors, now situated 10 to 12 feet below, surrounding street grade. Show commercial storefronts designed for street-level retail, positioned below what had become sidewalk level. Show the transition between buried original construction and later additions built to match elevated street level. The earthquake destruction exposed what normal conditions kept hidden, that San Francisco's pre-1890 buildings were designed for ground plane substantially lower than the elevated streets constructed after 1870's sediment deposition that city records acknowledge occurred, but minimize in terms of scale and impact. The retail configuration proves original design intent. Commercial buildings have specific architectural requirements. Street-level retail needs visibility, needs accessibility, needs display windows at heights, allowing pedestrians to view merchandise. The buried basement spaces in old buildings show these exact features. Show large plate glass windows at what would be eye level if street was 12 feet lower. Show door widths accommodating commercial traffic. Show ceiling heights of 12 to 15 feet appropriate for retail space, not 8-foot basement utility areas. Show built-in display cases and counters positioned to face windows that are now below sidewalk. The retail architecture proves these were ground-floor commercial spaces that became basements, when ground level changed not because architects designed underground retail, which makes no economic sense. Philadelphia's merchant directories tell the story through addresses. The 1875 directory lists businesses at street numbers, with designations like 128 Market Street, ground floor. The 1895 directory shows same buildings with addresses like 128 Market Street, basement level, or 128-12 Market Street, lower level. The addressing system changed because the physical relationship between businesses and street level changed. Businesses that were at grade in 1875 were below grade by 1895. The directories document this through changing location descriptors. Show businesses adapting by either relocating to upper floors now at street level or remaining in original spaces that had become basements, accepting reduced foot traffic and visibility that below-grade location entailed. The architectural rendering archives prove the discrepancy. Original 1860s, 1880s building plans show ground floor labeled retail space or commercial ground floor, with elevations referenced to street level. The drawings show entrance doors at grade. Show display windows at appropriate heights. Show proportions and configurations standard for street-level commercial construction. Compare these drawings to modern surveys of the same buildings. The ground floor from the drawings is now below current street level. The drawings weren't wrong. The buildings weren't constructed incorrectly. The street level changed after construction. The architects designed for ground plane that existed when buildings were planned, but which sediment deposition subsequently raised. The access ramp proliferation proves the adaptation timeline. Buildings constructed in 1850s, 1870s show ramps added in 1880s, 1900s, leading from original ground floor up to new street level. The ramps weren't original construction, show different materials, different construction techniques, appear in later photographs, but not in earlier ones. Were retrofit solutions allowing continued access from streets that had risen above original building entries. Eventually, the ramps were replaced with new ground-level entrances constructed at elevated street level, abandoning the original entries which became basement access if they remained functional at all. The sequential adaptation visible in construction history and photographic records proves the change happened during the 1870s, 1890s period, requiring businesses to modify access repeatedly as street levels rose. Washington, D.C.'s government building documentation is unambiguous. Treasury Building construction drawings from 1836 show ground floor at specific elevation above sea level. Modern survey shows that same floor is now 11 feet below current street grade. The building didn't sink. The foundation is stable, shows no settlement. The street rose. Similar documentation exists for Old Post Office, for original Smithsonian Castle, for dozens of government buildings where original construction specifications, including exact elevations, can be compared to modern measurements, showing street-level increases of 10 to 14 feet, while buildings remained at original elevations. Government documentation standards were rigorous. The discrepancies aren't measurement errors, are real elevation changes that architectural historians acknowledge in individual building studies, but never synthesize into recognition that Washington, D.C.'s streets rose approximately 12 feet during late 1800s. The construction newspaper archives reveal contemporary recognition of the changes. Articles from 1880s, 1890s discuss the buried storefronts problem affecting merchants. Describe business owners complaining about reduced visibility and foot traffic as their ground floor retail spaces ended up below rising street levels. Report on disputes between property owners and city governments over responsibility for access modifications. The contemporary accounts acknowledge the problem existed, describe it as gradual street elevation increase due to accumulated fill, without specifying where the fill came from or why multiple cities experienced identical accumulation patterns during the same decades. The articles document awareness of the issue while avoiding explaining its cause beyond vague references to inevitable urban development requiring street improvements. Nobody asks what happened to the first floors because the question seems to answer itself. They became basements. But that's not answer, that's description. The real question is how and why. How did street levels rise 10, 15 feet across dozens of American cities during the same 30-year period? Why did cities adapt by establishing streets at elevated grade rather than excavating to restore original levels? Why do architectural historians note the buried floors in individual building studies but never synthesize the pattern into recognition that American urban landscapes experienced dramatic transformation, requiring explanation beyond gradual accumulation or planned street raising that city budgets don't show funding and engineering records don't adequately document? The hotel registers provide human dimension to the statistical evidence. Grand hotels built in 1860s, 1870s with ground floor lobbies according to original descriptions. Guest registers from 1870s show room numbers beginning with 1 for ground floor accommodations. Same hotels in 1890s registers show room numbering, beginning with 2. The ground floor became basement storage or mechanical spaces, while what was originally second floor became the new ground-level lobby. Guests checking into what registers called street-level rooms were actually in spaces that were originally second floor, but which became functional ground floor when streets rose above the original first floor. The hotel operators adapted their numbering systems to match changed physical conditions without documenting what caused the change. The economic impact proves this wasn't minor adjustment. Commercial rent values tied directly to floor level. Ground floor retail commanded premium rates. Basement storage spaces rented at fraction of ground floor prices. When functional ground floors became basements, rental values declined proportionally. Contemporary business journals from 1880s, 1890s discuss the ground floor crisis affecting commercial real estate values. Calculate losses at 40-60% of property value for buildings losing street-level commercial frontage. Estimate total impact in millions of dollars across major cities. The economic documentation proves the change was massive, was widely recognized, was damaging to property owners who saw valuable retail spaces converted to below-grade storage through no action of their own, but through street-level increases that happened faster than buildings could adapt to. The photographic comparison methodology is straightforward. Library of Congress, city archives, historical societies hold thousands of 1870s, 1900s photographs showing American streetscapes. Select buildings still standing. Compare historical photographs to modern photographs. Measure door and window positions relative to street level. Document architectural features visible in historical photos that are below current street level. The methodology is simple. The results are consistent. Every comparison shows street levels 8 to 16 feet higher in modern photos than in historical photos, with buildings remaining at same elevations, proving the streets rose while buildings stayed in place. The photographic evidence is accessible to anyone willing to examine archives systematically. The building code evolution proves institutional recognition while preventing acknowledgement. Pre-1880 codes have minimal specifications for below-grade spaces. Because basements were rare in commercial construction, why build retail underground? Post-1900 codes have extensive basement requirements because thousands of buildings now had occupied spaces below street level. The codes adapted to existing conditions without explaining how those conditions arose. Required egress windows, required ventilation, required lighting standards for spaces that were originally designed as ground floor retail, but which street-level increases had converted to basements needing safety features. The original construction never anticipated because the spaces were meant to be above grade. The insurance industry records document the changed risk profiles. Fire insurance rates for ground floor commercial spaces were based on accessibility for firefighting. When those spaces ended up below grade, insurance companies reclassified them as high-risk basement locations with limited access and elevated fire danger. Rate increases of 50–100% were common for spaces that had been ground floor in previous assessment but were below grade in new assessment. The insurance companies recognized the changed conditions through risk calculations, even if their documentation doesn't explain what caused street levels to rise, converting previously accessible ground floor spaces into difficult-to-reach basement locations representing increased insurance exposure. The archaeological excavations that occurred during modern construction consistently find the hidden first floors. Developers excavating for parking garages or new foundations discover intact storefronts 12 to 15 feet below current street level. Discover display windows with glass still in place. Discover retail fixtures and merchandise remnants. Discover complete commercial spaces that were abandoned when streets rose above them and businesses relocated to new entries at elevated grade. The discoveries are documented in construction permits, in archaeological compliance reports, in developers' project files, are treated as curiosities rather than as systematic evidence, proving American city street levels rose dramatically during specific historical period that other evidence dates to 1870s, 1890s. The subway construction records reveal the buried floors from different perspective. When cities excavated subway tunnels in early 1900s, they frequently encountered building foundations extending much deeper than expected. Encountered structural elements indicating buildings had lower stories than above-ground inspection suggested. The subway construction photos show exposed building foundations revealing buried floors with windows and doors at what were supposed to be solid foundation depths. The subway builders noted these findings in engineering reports, described unexpected structural complications from building elements at depths where only foundation footings should exist. The reports document the evidence without explaining why buildings had constructed floors at depths supposedly too far below grade for occupancy. The modern basement conversion phenomenon proves the spaces weren't designed as basements. Real estate developers discovering that old building basements have 12 to 15-foot ceilings, large windows, architectural detail, and good proportions recognize these can be converted to valuable commercial or residential space. The conversions are profitable because the spaces have qualities appropriate for primary use, not utility storage, have the dimensions, the light, the finish that make them usable once access issues are resolved through excavation or internal connection to upper floors. The market recognition that these spaces have value proves they weren't designed as basements, were designed as premium ground floor spaces that became basement storage only when street levels changed after construction. The preservation battles reveal institutional resistance to acknowledging the pattern. Historic preservation requires maintaining buildings in original condition. But how is original condition defined when original ground level is 12 feet below current street? Preservationists face dilemma. Maintain the building as it appears now with elevated entries and buried first floor, or restore it to original configuration, requiring excavating sidewalks and lowering streets to original grade? The choice is always maintaining current condition because restoring original ground level is economically impossible. But the preservation documentation rarely discusses why the dilemma exists, why original and current conditions differ so dramatically, what happened to create the discrepancy, requiring preservation decisions about whether to maintain the modification or restore the original. The tourism industry exploits the buried floors without explaining them. Underground tours in Seattle, Portland, Chicago, and other cities take visitors through underground passages and storefronts. Market these as mysterious buried cities. Present them as curiosities without explaining they're not actually underground, but are original ground-level commercial districts that street-level increases left below current grade. The tours generate revenue from the mystery while avoiding the explanation that would make the mystery less mysterious, but would require acknowledging that American street levels rose dramatically through process that official urban history inadequately explains, through vague references to planned street raising that engineering and financial records don't support. The title insurance complications prove the legal implications. When property surveys reveal buildings have more floors than title records indicate, title insurance companies must determine whether the buried floors are included in property description. Often the descriptions reference 3-story building when survey shows 4 stories with 1 below current grade. Do property boundaries extend to buried first floor or only to current basement, which was originally second floor? The title questions reveal that legal descriptions of property don't match physical reality because physical reality changed after legal descriptions were written. The complications create ongoing legal uncertainties about what exactly property owners own when their buildings have hidden floors that original deeds may or may not have included, depending on how ground floor was defined at the time. The climate control problems in old buildings trace to the buried first floors. HVAC engineers struggle to heat and cool old commercial buildings efficiently. Discover the buildings have thermal characteristics inconsistent with assumed structure. Investigation reveals buried floors creating thermal bridges between heated spaces and ground contact. The floors weren't designed for ground contact, were designed for ventilation and thermal isolation appropriate to above-grade construction. Current below-grade position creates heat loss, moisture problems, and thermal inefficiency that original design didn't anticipate. Though HVAC complications prove the buried floors aren't original basements, but are above-grade construction performing poorly in below-grade position. The flooding patterns prove the buried floors create vulnerability, original construction avoided. Old commercial districts flood during heavy rain because water enters through buried first-floor windows and doors. Original construction positioned these openings above flood levels that engineers would have calculated. Current position below street level puts them at exactly the elevation where water accumulates during storms. The flood damage is modern problem, not historical one, result of street-level increases, putting original ground floor openings into vulnerable below-grade position they were never designed to occupy. Contemporary flood maps showing old districts as high-risk areas are documenting consequences of street elevation changes, not inherent site vulnerability. The material conservation challenges prove the buried floors weren't meant for ground contact. Masonry and architectural elements on buried floors show deterioration from extended earth contact. Show moisture damage, show biological growth, show material breakdown that above-grade portions of same buildings don't exhibit. The differential deterioration proves the buried portions weren't designed for burial, were constructed with materials and techniques appropriate for above-grade exposure, are failing now because ground contact creates conditions the materials weren't specified to resist. Conservation architects note these problems in condition assessments without asking why valuable building facades were constructed with materials unsuitable for ground contact, unless the construction wasn't originally at ground level. The demographic data correlation is striking. Census data shows American urban population growth 1850-1900 concentrated in areas showing buried first-floor evidence. The population surge supposedly driving need for urban expansion and infrastructure improvement. That official explanation cites as reason for street raising. But timing is reversed. Population growth accelerates after the street level changes, not before them. If street raising was response to population pressure, it should precede or coincide with growth. Instead, growth follows the changes suggesting population movement into cities was response to something that happened in 1870s, 1890s, creating opportunity or necessity for urban concentration in same period when street levels were rising. The global comparison proves American pattern isn't unique. European cities show identical evidence: buried first floors, changed street levels, commercial spaces converted to basements. Same timeline, same elevation differences, same adaptation patterns, same inadequate official explanations. The global coordination proves common cause: mudflood deposition raising street levels in urban areas worldwide, while architectural histories in each country independently develop local explanations, avoiding recognition of global pattern. American hidden first floors are American manifestation of worldwide phenomenon that architectural history treats as collection of unrelated local events, rather than recognizing as global pattern requiring systematic explanation. The recovery pathway requires three components. First, systematic documentation of buried first-floor evidence across multiple cities building comprehensive data set. Second, financial analysis, proving planned street-raising scenarios don't match city budgets or construction costs. Third, photographic timeline showing the change occurring within specific narrow window matching mudflood chronology. The evidence exists for all three. Architectural surveys document the buried floors. Financial records show the missing expenditures. Photographs document the timeline. What's missing is synthesis into comprehensive case that American street levels rose 10 toward 15 feet during 1870s, 1890s through sediment deposition, not through planned engineering requiring acknowledgement of catastrophic events affecting urban infrastructure worldwide. What happened to America's hidden first floors isn't mystery requiring speculation. Documentary, photographic, and physical evidence prove they were buried by rising street levels during late 1800s. Prove street levels rose through sediment deposition, not through planned municipal improvement. Prove cities adapted to changed conditions rather than engineering the changes deliberately. Prove property owners lost valuable commercial space as street-level retail became basement storage. Prove insurance companies recognized increased risks from below-grade positions. Prove building codes adapted to regulate spaces that weren't supposed to exist below grade. Prove the evidence is comprehensive, is consistent, is accessible to verification. What's missing isn't evidence. Is framework allowing recognition that the evidence proves American cities experienced rapid dramatic street-level increases through process, that official urban history explains inadequately through street-raising claims that financial and engineering records don't support, but which mudflood deposition explains completely, matching timeline, matching pattern, matching evidence visible in buried first floors showing commercial architecture designed for ground level that ended up 12 feet underground, creating ongoing complications for property use, for building systems, for preservation decisions, for title descriptions, for flood vulnerability, all tracing back to catastrophic changes affecting urban elevations during specific historical period that other evidence proves was global mudflood deposition burying not just Tartarian territories, but American cities, converting their first floors to basements, while official histories developed local explanations avoiding recognition of global pattern, leaving the evidence preserved architecturally in thousands of buildings across dozens of cities, waiting for systematic examination that proves America's hidden first floors aren't hidden, are buried, are accessible through excavation, are documented in archives, are visible in photographs, are measurable in modern surveys showing street elevations 12 feet above original ground plane, proving the change happened, proving it happened suddenly, proving cities adapted rather than engineered it, proving the mystery only exists because asking what happened leads to answers requiring acknowledgement of catastrophic mid-1800s events that progressed narratives can't accommodate.